We've got a few quotes from the people who will actually be sitting down and marking your exams, as well as those who help devise the questions, those devious people. They say many students experience difficulties by missing important details in both questions and their answers. There were a number of questions where it was obvious candidates had not read the question properly. I mean, who among us doesn't do that from time to time? I'm sure at some point today, I'll probably commit that error. The paper is set so that the questions cover the specification as widely as possible and test as many skills as possible, which means, unfortunately, that it's no good sort of picking and choosing topics to revise. You're going to have to try and cover the entire syllabus as best you can, which is exactly what we're going to do today. So, pushing on. The first thing I said I wanted to talk about was interpreting questions. On the right, we've got a fairly typical exam question. And I want to point out the three elements that will be in pretty much every exam question you come across. The vast majority of it is context. You'll read the first two paragraphs. There'll be a few words that give you an indication of roughly what area of the syllabus you're talking about. In an exam, you're not guaranteed to get questions on each topic as it appears in your textbook. It'll be all jumbled up, and fairly rapidly, it helps to work out, roughly what topic you're talking about. Start trying to remember as best you can the relevant formula, the various facts. Key to the question will be command words. These tell you what you actually are expected to do. So describe, explain, know the difference between those two. We'll go through that in a bit more detail. And finally, directions. These are not always present, but directions will be the parts at the bottom here, where they just remind you exactly what you're being asked for. Yeah, particularly with calculation questions, sometimes you can get a little bit lost in the weeds. So the context is all of this stuff over here. You read it, a teacher uses a linear air track. I'm already thinking something to do maybe with collisions, frictionless collisions. Right, the answer says to provide a frictionless surface for two gliders, each of mass m. As soon as they start talking about mass, I'm thinking it's got to be mechanics. She uses this with a pair of light gates connected to a computer to investigate a collision between the gliders. Okay, so hopefully from the context, we can already start sort of doing a little bit of advanced thinking before we've even finished reading the question. What does it actually want? Our command word here is integral. Calculate. It wants an answer. It wants a numerical answer. Right. In terms of this question, then, I said I suspected it was about momentum. I happened to be correct this time. Hooray for me. Two gliders going into each other. As with most questions, it's worth starting with just pointing out a few physical facts. Momentum. The key reason we're interested in it is because it's conserved. So you can write momentum before equals momentum after. You can also tell us what momentum is, mass times velocity. It's this mathematical construct that we love because it's conserved. They tell us that they are both of mass m. That signals to you that it's okay to use the algebraic expression m. You don't need to sort of be aware of its specific mass. They give you the initial velocity of glider 1 and the initial velocity of glider 2, and they tell you what direction they're in. It remains then to choose. I always suggest that you choose taking right as positive, or if you're talking about vertical, choose up as positive. It keeps things a little bit simpler to have a standard convention. And so one glider is going 0.3 meters per second to the right. The other is going to the left, hence this negative sign. And that's got to be equal to their joint momentum as they go off together afterwards. The question says they're each given a small push towards the center. They glide and move off together. Key information. A little bit of algebra later, and you end up with your answer as V is minus 0.2, What does the minus mean? Well, by our convention, we said right was positive, so it's going to be going to the left. And the magnitude of the velocity is just 0.2 meters per second. Please don't forget units. Examiners hate that.